Welcome to a lesson with Dr. Powell. Let's take a look at an interpretation of a surface integral with a vector field. Now, naturally, our aerial projections are orthogonal to the surface, and if the surface is connected and oriented, that orthogonality is going to stay the same. So if we go back on the other side, it's pointing opposite, in the opposite direction as it goes around and meanders. Such a thing is called an oriented surface as we move around. Now, what if this is closed and we're kind of thinking about the flux with inside of this of a vector field? Well, our vector field naturally is just done by dotting with these anyway, with the vector variable projections. And so you can kind of think about it as going along here. So it really is just flux. Surface integrals in some sense are just flux of a vector field if you have an enclosed thing right here. Now if you, since the integral of the surface is flux is kind of another way of thinking about it is like divergence, like how much we're diverging from a point. So if we switch that up and thought of via Stokes' theorem, vector field that or a value even we can integrate in the volume, that's called the divergence. So it measures how much flux we have when we have enclosed surfaces. Hence the words flux and the word divergence. So flux is just a measure of how much of the vector field is related to how much it's like going out from this particular surface. Thanks for watching.